A zener diode with breakdown voltage 5.6 volt is connected to a 9 volt supply through a 200 ohm resistance in series and a 800 ohm resistance in parallel. Determine the current through the diode. So in this problem, the breakdown voltage of the zener, it is given 5.6 volt. This is the zener diode, and the connected supply voltage, this is the unregulated supply voltage, which is equal to 9 volt, and this is the series resistance, 200 ohm series resistance, which is connected to the diode, zener diode in series, and this is your parallel resistance, 800 ohm parallel resistance, which is connected to the zener diode, and we have to find out the current through the zener diode. To find the current through this zener diode, we have to first find out the what is the current through this load resistance of 800 ohm, because current, then we will find out the current through this 200 ohm resistance, and current through this zener will be equal to the current through this series resistance minus current through this load resistance. That will be the current through this zener. So the voltage drop across the load resistance is equal to 5.6 volt, because this load resistance is connected in parallel to this zener diode. So voltage drop here is equal to 5.6 volt. So what will be the current through this load resistance or 800 ohm resistance? The voltage drop is across 800 ohm resistance is 5.6 volt. So current through this 800 ohm resistance will be equal to voltage divided by resistance. Simply you apply the formula of Ohm's law, V equal to IR. So I will be equal to V by R. So 5.6 divided by 100, that will be equal to 0.007 ampere or 7 milliampere. Now we'll find out what is the voltage drop across this resistance 200 ohm. The supplied voltage or unregulated voltage is 9 volt, and the voltage drop across this zener diode is 5.6 volt, or across this load resistance is 5.6 volt. So voltage drop across this series resistor will be equal to 9 volt minus 5.6 volt, that will be equal to 3.4 volt. So voltage drop across this series resistor will be equal to 3.4 volt. So what will be the current through this series resistor? Current through this series resistor will be equal to voltage divided by resistance. Voltage is 3.4 volt divided by 200 volt. So that will be equal to, if you divide, then that will be equal to 3.4 divided by 200. So it will be equal to 0.017 ampere or 17 milliampere. So what will be the current through this zener? The current through this series resistor is equal to 17 milliampere. So current through this zener will be equal to 17 milliampere minus 7 milliampere, because 7 milliampere current have passed through this or have gone to this load resistance of 800 ohm. So through this zener, the current will be equal to 17 milliampere minus 7 milliampere, that will be equal to 10 milliampere. So in this way you can calculate the current, amount of current passing through the zener diode, which acts as a voltage regulator. That is why it is called a voltage regulator, because here you see voltage is fixed and the current, whatever current you pass through this zener diode, the voltage will not change. That is why it acts as a voltage regulator. Thank you.